Hello everyone, I'm Steve Mundy, a Principal Technical Support Analyst, and in today's webinar we'll be looking at understanding and troubleshooting blackout policies. Here is the agenda for today. We will start off with why there is a need for blackout policies, before looking at how to choose the right blackout policy. We will then look at troubleshooting, as well as going through how to avoid some common issues, and finally onto the documentation references. There are various reasons why a blackout policy is needed. The most common is that a particular server or application is in a maintenance window due to an upgrade or patching, and you do not want your monitors or devices to be in alarm and flag a problem during that window. So what is a blackout policy? To put it simply, it is a policy that can be created to black out data and events from patrol agents and also black out events from other third-party type events. A blackout policy can also be created against a configuration item, otherwise known as a CI, such as a computer system CI. It can be difficult to know which type of blackout policy to set and where, as there are different types that can be created, and we will go into each one in more detail in the next slides. This simple table should help though. The first column in the table shows the different blackout policies and where they can be created. The rest of the columns indicate what can be blacked out. The color coding indicates in which component the blackout is set. If we look at the first one, the blackout for patrol agent can be used to black out data from the patrol agent, black out intelligent events, which are the alarm and abnormality class events, and also black out patrol events. Even though it is created in the TrueSight console, it is pushed down and set in the patrol agent. The standard and dynamic blackout for events can be used for events reaching a TSOM cell and include intelligent events, patrol events, as well as third-party events. This is created in the TrueSight administrator console and set in the TSOM cell. The component blackout for events can be used to black out those events reaching a TSOM cell that would impact a CI, and again this is created in the TrueSight administrator console and set in the TSOM cell. If integration with ITSM change management is configured, a change request created in the change management console would set the status of the CI to be blackout, and also black out those events that would impact a CI. This is set both in the TSOM cell and also in ITSM. Let's now take a look at the different policies in more detail. A blackout policy for patrol agents can be created in the TrueSight console, which can be otherwise known as the TSPS console. This type of policy will be pushed down to those patrol agents that meet the agent selection criteria and can black out data, events, and recovery actions. The policy can specify either to black out the complete patrol agent or specific monitor types, such as processor, as an example. When creating the policy, an existing timeframe must be selected, so make sure the timeframe has already been created first. This type of policy can black out alarm events generated by rate process and events of class patrol_EV that the patrol agent generates, but it will not black out the self-monitoring events of class ppm_SM_EV. For example, that type of event would be generated by the agent controller process when a patrol agent has disconnected from the integration service. Finally, this type of blackout policy can also be created through REST API. Moving on to the next type of policy, we have what is known as a standard blackout policy for events. The TSOM administrator console is used to create this type of policy in the cell itself. As with all event policies, an event selector is used to match events to the policy. Different actions can be selected for the start, during, and end of policy. At the start of blackout, any pre-existing events can have their status unchanged or they can be put into blackout status. During the blackout, new events can either be put into blackout status or they can be dropped. At the end of the blackout, events can either be left in blackout status or they can be changed to open status. This type of policy can also be created from the command line by using msend to send into the cell an event of class blackout_EV with the required slots. Out-of-the-box rules in the cell for blackout_EV class will then create the blackout policy automatically. Similar to standard blackout policy, a dynamic blackout policy is also created in the TSOM administrator console. It makes use of a match table, which is similar to a dynamic enrichment policy. It is not as flexible as a standard blackout policy, as it is not possible to specify any start, during, or end actions. During the blackout, new events that match the policy will be placed in blackout status. At the end of the blackout, events are not changed to open status, they will remain in blackout status. Moving on to the next type of policy, we have a component-based blackout policy, which again is created in the TrueSight Administrator console. Its purpose is to black out those events that are associated to a specific CI, which results in the CI not being impacted by the blacked out causal event. Just like standard blackout policy, there are start, during, and end actions that can be specified. Finally, the last type of blackout policy is one that is created with integration to ITSM change management. Creating a change request in change management will result in a time frame and policy being automatically created in the TSOM server cell. The CI for which the change request is against must be a CI that has previously been published from CMDB to TSOM. Just like a component-based blackout policy, its purpose is to black out those events that are associated to a specific CI. This type of policy must not be edited in the TrueSight Administrator console, but it can be viewed. The default start, during, and end actions when the policy is automatically created can be altered by changing the value of the bppm.rule-configurator.blackout policy prefix properties in the tsimpronet.conf file. We will now take a look at some of the blackout policies. We will first take a look at the blackout policy for Patrol Agent, which is created in the TrueSight console. Here is the TrueSight console, and on the left-hand side, under Configuration, Infrastructure Policies, we can see here there is a tab for blackout, and that's where blackout policies can be created and viewed. But before we create a blackout policy, we have to ensure that there is an appropriate time frame in place. So we'll go down to Infrastructure Timeframes, and for the purposes of the demo, I'll be creating an ad hoc blackout for only a few minutes of duration. Click on Create Time Frame, give it a name. Under Recurrence Frequency, we can see that there are options: always active, once, daily, weekly, monthly. This is going to be a ad hoc one, so I'm going to select once. And then here we have a calendar where we can select a date. Then the start time, I'll have it start as it's shown here, 13:45, and it will be a 15 minutes duration. So I can either specify an end of 1400 as shown here, or I can specify a duration of 15 minutes as shown here. Save the time frame, go back to Infrastructure Policies, Blackout, Create Policy, provide a name, select the agent selection criteria. It's just for one specific host, prodserver1.bmc.com, select Preview, and we can see here the Patrol Agent is listed. Provide a unique precedence and enable the policy. Select the time frame, which is the ad hoc one we just created. Then on the Scope tab, we can see here, blackout can be applied to complete agent or specific monitor types and instances. If we look at monitor types and instances, click on the Add Monitor Type, Microsoft Windows Servers, and here you can see the different monitor types listed. And for example, you could black out just specific ones here. For the purposes of the demo, we're going to be selecting Complete Agent. And then you have the scope of what is to be blacked out. If data is selected, that includes events and recovery actions as well. If data is unselected, then events and recovery actions can be selected. And by events, that just relates to the events of class patrol_EV. But we're going to select data, which includes everything. The selection at the bottom, do not send blackout start-stop events. If that is unchecked, then at the start of the blackout period, information events will be generated for each monitor type, indicating the start of the blackout. And at the end of the blackout, again, information type events are generated for those monitors, indicating the end of the blackout. But we will have that selected so that we don't have those events. Save the policy, go to Manage Devices. Here is my agent, ProdServer1. Go into Query Patrol Agent, and we're going to execute the command to retrieve all the pconfig variables. And here we can see a pconfig variable, config data agent setup blackout, which is the details of the blackout. It has the scope of the blackout, the start, and the duration. So that has been pushed down to the patrol agent from TSPS. If I just refresh this page under Manage Devices, notice now that this icon here has appeared under Additional Info column, which indicates that there is a blackout policy applied to that patrol agent. Let's now go across to that patrol agent machine and stress the CPU. Here is the patrol agent machine. We can see here in Task Manager, CPU is normalized around about 2-3%. And I have this free utility which I downloaded from the Microsoft Sys internal site, which can be used to stress the CPU. CPU is now stressed. We can see here in Task Manager, CPU is at 100%. Let's go back to the TrueSight console now. Still under Manage Devices, go back into the Query Patrol Agent, and we'll execute this dump his command, which has a start of current time less 300, that's 300 seconds, 5 minutes. So this will pull out the data points from the patrol agent history file of the last 5 minutes. And we can see here that the most recent data point here is 1344.44. So there's been no data points since the blackout that started at 1345. Be mindful that the patrol agent caches history data points in memory, and they're only flushed to the history file at every 16 data points. For the purposes of this demo, I've modified the patrol agent pconfig variable agent setup /prm hist cache size to disable the history cache so that every data point created gets immediately written to the history file. It's not advisable to do that in production, as that could have a small performance impact. Let's now go back to the patrol agent machine and stop the patrol agent. On the patrol agent machine, go into Services, stop the patrol agent, go back to the TrueSight console, and here in the TrueSight console we can see that we have a self-monitoring event that's been generated indicating that the patrol agent has disconnected. So even though the patrol agent has been configured with this blackout policy to black out data and events, if the patrol agent is stopped, you will still see a self-monitoring event, because that event is not actually generated by the patrol agent, but it's generated by the TSOM server agent controller process. If you wish for that type of event to be blacked out as well, then you would have to create a standard blackout policy for events in the TSOM administrator console. Let's now go and start that patrol agent back up. Patrol agent has now started. We can still see that the CPU is at 100%. Let's now go back to the TrueSight console. And that patrol agent disconnection event has cleared because that patrol agent has now reconnected back. Go back into the blackout policy. I'm just going to make a small change to it. Under scope, we're going to unselect data so that events and recovery actions are still selected. What this means is that the patrol agent will now start collecting data and stream that to the TSOM server. Go back to Manage Devices, Query Patrol Agent, execute the same dump his command again. And we can see here that some data points have been collected now. And back in the events page, we can see that we have this event that's been generated indicating that the processor is high. And it's an alarm event. So that even though in the blackout policy we have events selected to be blacked out, that only applies to events of patrol_EV event class. Because we have data not selected and data is being streamed, then we will get alarm and abnormality type events still generated. Let's now just wait for this blackout policy to finish at the designated time. And in the Manage Devices page, we can still see the icon to represent there's the blackout policy in effect on that patrol agent. We've now reached the end of our blackout period. And just refreshing that page, that icon has now disappeared. Back in the events page, we can now see these additional events for CPU processor, which are of class patrol_EV, which the patrol agent has generated. This concludes the demo portion for blackout policy for patrol agent. Let's now move on to the other types of blackout policies now. We will now take a look at standard and dynamic blackout policies for events, which are created in the TrueSight Administrator Console. And these types of policies will be used to black out events in the TrueSight cell. So in the Administrator Console, we go to the Event Policies tab by clicking on this middle icon here. We expand the group, and then we can see the cell there, PN_cell_TSOM1. We expand that, we can see folder for selector and policy type. Just expand those. So we will create a standard blackout policy here. But before we do that, we will create an appropriate time frame. Now for this type of policy, if no time frame is specified, then that policy will be always active. So to create a time frame, we can either go Tools, Time Frame Editor, or we can click on the calendar icon here. Click on the second icon, New Time Frame, give it a name, and then we can specify a start and end time. I'm going to specify a time of 09:45, and even though we do not see that in the selection list, you can actually key in this field. For the end, a time can be specified or duration, and I'm going to specify a duration of 5 minutes. Select time zones. If that is unselected, then that will use the local time zone of the cell. Mark this as permanent time frame. If that is unselected, then it means that once all the blackout policies that reference this time frame are deleted, then this time frame will automatically be deleted as well. Recurrence pattern, you can see here daily, weekly, monthly, yearly, date list, and a repeat cycle. As this is a one-off, I'll specify daily, and range of recurrence, just one occurrence. Save that. I will then go and create a selector because I want to black out patrol events for a specific host. Click on Add Event Selector, give it a selector name, Prod Server 1, and I need to select patrol events in the pull down list. Patrol event. And this is where you provide event selection criteria. So for a specific host, we'll choose the host slot with a specific value of Prod Server 1. Insert, OK, OK. That selector is now saved. We now go to Blackout Policy, click on Add Event Policy, and in the selection list, choose the selector we just created, Prod Server 1, give it a name, BO Demo 1, and here you can specify it's always active or use a specific time frame. We will select the one that we just created called Demo 1, so we select Active Time Frame Demo 1, and this is a multi-selection window, so you can select multiple time frames here if you wish. You can also specify non-active time frames. And then we have the options here. So at the start of the blackout window, if there are any existing events, leave those status unchanged or change them to blackout. During the blackout window, the option is to either black out new incoming events or discard them. We will set this to black out the incoming events. And then at the end of the blackout window, we can either leave those blackout events in the blackout status or they can be changed to open status. So we'll change them to open status. Click on OK, so that policy is now enabled. Here is the TrueSight console. In the top right, it's showing a clock time of 09:43. So let's just wait for it to become active. It's now 09:45. The blackout policy is now in effect. Let's now go over to the patrol agent machine and stress the CPU. Here is the patrol agent machine. I'll use that utility again to stress the CPU. And we can see here that the CPU is now at 100%. Let's go back to the TrueSight console now. And we can see here that we have some events that have been generated and they are in blackout status. If we drill down into the event details for one of them, we can see here status blackout. And if we click on the Log and Notes tab, we can see that there is information here that mentions that it's blacked out and the name of the policy which was responsible for the blackout. So it's a 5-minute blackout. Blackout will finish at 09:50. Let's wait until that time and see what happens to these events. It's now 09:50. The blackout period is over. Let's refresh this page. And we can see here that the events have changed from blackout status to open status as expected. The other thing that we can do with a standard blackout policy is it can be created from the command line. So imagine the situation, you get a phone call from one of your co-workers saying that there's an emergency, we need to black out events of class Nagios for the next 2 hours. Can we put into place a blackout policy immediately? So you could go back into the administrator console, you'd have to create a time frame, you'd have to create a selector, you'd then have to create the policy. But the alternative is that an event can be sent into the cell with certain slot values that can create the time frame selector and policy automatically. And there are out-of-the-box rules in the cell that perform this. So let's just go to a command window. So we'll use the msend command to send an event into the cell. -n is the cell name. -a option is the event we will send in. It has to be an event of class blackout_EV. -b option are the slots that we have to give it. We have to give it a name. So blackout name equals, and we'll, just for the purposes of this, we'll just call it emergency Nagios. That's one slot. The other slots we have to provide are either an existing time frame and selector, or the duration of the blackout and the class that's to be blacked out. So we can specify a specific duration here of 2 hours by specifying blackout_duration slot with a value of 2H. And then we can provide another slot based on class. And here we provide the name of the event class to be blacked out, Nagios EV. Execute that, go back to the administrator console, have a look under blackout policy. We can see here we have the blackout policy has been created. It's using a time frame which has also been created, and it's using a selector which was also created automatically. If we go to the time frame editor, you can see here this was the time frame that got automatically created. Notice in the blackout policy options that it's used the default of, at the end of the blackout window, leave blackout events in blackout status. Maybe we don't want that. Maybe we want at the end of the blackout the events to be reopened. So you can either edit this policy in the admin console, or you can send another event into the cell which will update this policy. We will run a similar msend to update the policy. So just repeat the command. We have to give it the name, emergency Nagios. We provide a slot end_action, and it has a value of im_blackout_actions.reopen. Go back to the administrator console, click somewhere else, and then click back on the blackout policy for the Nagios one. And notice here it's changed it. Let's now send in a test Nagios event. -m for message, and -r for severity. Go back to the TrueSight console, and here is the Nagios event. We can see it's in blackout status. Now your coworker calls you again and says, actually, the panic is over. We don't need this blackout policy anymore. Can we get rid of it? And again, that policy can be deleted by sending in an event into the cell. And like before, it's event class blackout_EV. We have to give it the slot of the blackout name, and then we give it a slot delete_blackout with a value of yes. That's now deleted. Let's go back to the administrator console, and we can see here that that policy has been deleted. If we go into the time frame editor, we can see that the ad hoc time frame that got automatically created has also been deleted. Having the ability to create, update, and delete a standard blackout policy from the command line by sending in a simple event is very powerful. And as that policy has been deleted, if we go back to the TrueSight console, we can see here that this Nagios event is now open status. Let's now take a look at a dynamic blackout policy. Let's create one for the purpose of this demo. Click on Add Event Policy. We're going to choose a selector. We'll pick all events. And here you have the policy details to complete. Give it a name. Execution order. Think of this as precedence order. So the lower the number means it will get executed first. You can specify a time frame, either always active or choose one. We'll have this always active. And then you have to specify match fields. So this is similar to a dynamic enrichment policy where you will specify match fields. Here we're just going to choose host, and then you have to specify the CSV file which contain the details. Let's just take a look at a CSV file that I already created. Here is a CSV file, and it just specifies some host name prefixes. So prod server, Houston, London. What this will mean is that any event that has one of those values for the host slot will be blacked out. And for the match table, we have to specify the location of the CSV file. Click on OK. Policy has been saved. It must import the data. Do you want to import it now? Yes, we do. Takes you to the Import tab. Going to Import. 3 records have been imported. Let's now send in some test events. So send in a test event, severity critical, and we will give it a value for the MC host slot. Go to the TrueSight console. There is the event there, and we can see here it's blacked out, prod server. Let's send in some other events. So some events have been sent in with different values for MC host slot. So we can see here which ones have been blacked out and which ones haven't. The thing to understand with dynamic blackout policy is that it's not as flexible as a standard blackout policy. Notice that there aren't the options to specify start, during, and end. So during the blackout, the events will change to blackout status, but at the end of the blackout period, events won't reopen. They will stay in that blackout status. So just be mindful of that if you consider using a dynamic blackout policy. If we edit this policy now and disable it, by unselecting the enabled checkbox, go and send in another event, host prod server 1234, and then in the TrueSight console, we can see here it wasn't blacked out because the policy is disabled, and events that were blacked out while the policy was enabled are still blacked out. They will remain like that. And this concludes the demo on the standard and dynamic blackout policies for events. It's not nice when things do not work as expected. Examples of this can be a patrol agent that does not come out of blackout at the end of the blackout period, or events are not getting blacked out despite an event blackout policy being in place. Listed here are the key data required should you wish to try and troubleshoot the problem yourself or for BMC support to investigate a problem. If a problem is faced with a blackout policy for patrol agents, the information that would aid investigating that problem are the CMA.log from TSPS, a pconfig from the patrol agent to be able to check the value of /config data /agent setup /blackout variable, copy of event in Baroque format, and details of the policy such as screenshots. For the other types of policies that are all created in the TSIM cell, copy of event in Baroque format and details of the policy, the associated selector and time frame, and also the cell KB. Having a copy of the cell var directory is preferable as that will contain the required information. Let's now take a look at how to avoid some common issues. If there are multiple blackout policies with the same agent selection criteria and the same scope, that is, the policies are all of scope complete agent or all of scope monitor instance, and the monitor instance is the same, then only the one with the highest precedence is applied to the patrol agent. To prevent this issue, either have a single policy with the multiple timeframes, or once a timeframe is no longer active, for example it was used for an ad hoc blackout, then disable the associated policy. An error would be seen when trying to create a time frame that starts before midnight and has an end time at or after midnight. For example, start of 2300 hours and end of 0100 hours. In this example, it will be necessary to specify duration rather than specific end time. If there is an event blackout policy, either standard or dynamic, that is not being triggered and the selector for the policy is based on enrichment by a custom rule, this will be due to the custom rule executing after the policy-related rules, which are in the im_internal.mrl file. The solution is to modify the .load file in the cell KB rules directory so that the custom rule is executed before im_internal, then recompile and reload the cell KB. If there is a cell event blackout policy, which is using a time frame and the time frame is active across the daylight savings time change, then the policy will not become out of schedule at the expected time. This is due to there being no reference to time zone in the time frame data instance. To resolve this, in the TrueSight Administrator console, go into Timeframe Editor, modify the time frame, and select the appropriate time zone. This references slide has doc links on creating the various types of blackout policies, as well as how to integrate with change management. In summary, we covered an overview of what a blackout policy is and its purpose. We took a look at the different policies before moving on to the type of data to collect to assist in troubleshooting an issue with a blackout policy. Finally, we reviewed how to avoid some common issues. And that concludes my presentation.